So today we are going to discuss the topic of continuous wave radar. So what is the CW radar stands for continuous wave radar. So this CW radar detects objects and measure velocity from Doppler shift and also measure the range. CW radar is continuous wave radar and it is based on the concept of Doppler effect. So CW radar is used to determine the relative velocity of target with respect to the radar. So what is a CW radar gives? CW radar measures the bearing of the object, elevation angle of the object, and it is used to navigate over the land or sea. So here the continuous radar can be used to differentiate the detect the target of the moving target. So now this radar CW radar works with the principle of Doppler effect. When the source of the oscillations or observer of oscillations is in motion, an apparent shift in frequency will result. This is known as Doppler effect. When source of the oscillations or observer of oscillations is in the motion, an apparent shift in frequency will result. This is known as Doppler effect. So the Doppler effect means change in frequency. So how the frequency is going to be changed. So here we can see that three types of waveforms. One is with a higher frequency, one is operating frequency, one is lower frequency. When the object is far away from the radar, it gives the low frequency signal. So when the target is near to the radar, it gives the approaching to the radar, so it will give the high frequency. See the first waveform, F0 plus Fd. So here the frequency is high, so we are getting the approaching. So F0 is the operating frequency. If you get the F0 plus Fd until F0 at the receiver radar, you are getting higher value than the operating value. We can say that the target is approaching. If you are getting the lower value than the operating frequency, then we are telling that it is a receding. So when energy, we can define this in terms of sound waves. So when a wave energy like sound or radio waves travels between two objects, the wavelength can be seems to be changed if one or both of them are moving. This is called the Doppler effect. See here the sound waves transmitted and received, no change in distance between source and receiver. Increasing distance both sound and receiver, so the distance is increased. When the sound waves are near to, decreases the distance between source and receiver. So this is the example of Doppler effect. Example for this we can tell is when ambulance is horning, it is far away, we can't hear, we are hearing with the low noise. When the ambulance is reaching to the near to us, the sound is more. So this is the Doppler effect. So now we will see in detail about the Doppler effect. So Doppler effect means displacement of frequency due to the motion of target. What is the Doppler effect? Doppler effect means displacement of frequency due to motion of target. The presence of frequency shift in the received echo signal in the radar due to the moving of the target is known as Doppler effect. A feasible technique for separating the received signal from the transmitted signal when there is a relevant motion between radar and target is based on the recognition the change in the echo signal frequency caused by the Doppler effect. The change in frequency called as Doppler shift. So the radar radiates EM wave towards the target for detection and also to obtain the details of the target. When the target is stationary, the frequency of the received echoes is constant. When the target is moving, the frequency of echoes are found to be different from transmitted frequency. Now we will see the changed frequency. If the target is closing to the received energy, we will have the frequency Fr is equals to F0 plus Ft. So frequency increases. If the target is moving away from the received energy, we will have the frequency Fr is equals to F0 minus Fd. Frequency increases, frequency decreases. So now we are going to find the relation of the So now we are going to find the relation between FD and VR. So if suppose the range of target is R, the wavelength is lambda, the VR, the relative velocity of target with respect to the radar, the energy travel from the radar antenna to the target and from the target to the radar. The total wavelength is 2R by lambda. Their phase change in radiance is 2 pi. Has the energy travel in two ways, so the total phase change is phi is equals to 2 pi into 2r by lambda. So phi is equals to total phi is equals to 4 pi r by lambda. The r will change continuously as the target is in the motion. So the phase will also change accordingly. A change in phase with respect to the time may be called as angular frequency. So a change in phase with respect to the time may be called as angular frequency. So W is equals to d phi by dt. Phi is the phase angle. So we can write W is equals to 2 pi fd, 2 pi f rayachu. So here fi I consider the Doppler shift. 2 pi fd is equals to 4 pi Vr by lambda. Ft is equals to 2 Vr by lambda. If the Doppler frequency Fd is in Hz, Vr is in kilonewtons, wavelength lambda in centimeters. So Fd is equals to, in terms of kilonewtons per centimeter, the Fd is equals to 103 Vr kilonewtons by lambda centimeters. Fd is equals to 1.03 Vr kilonewtons by lambda centimeters. So how this Fd is equals to in 2 Vr by lambda is changed into 103 is, so 1 meter is equals to 0.58, 1 kilowatt is equals to 0.58 meters per second. So so I have converted that meters per second into kilonewtons. So if we are having this formula, when it is applicable, there is a 0, that theta is 0. What is the theta here is, if the angle between the target and the radar antenna is theta, then the radial velocity, and if the theta, what you mean by theta is the angle between the target and the radar antenna is radar antenna. So if I am considering theta is equals to 0, so here what you are going to tell is, what is the theta is, if the angle. So here what is the theta is, if the angle between the target and the radar antenna is theta, then the radial velocity is Vr is equals to V cos theta. So theta, if we are taking the 0, we are going to get the Ft is equals to 2 Vr by lambda. So here what is the phi? So phi, I have substituted phi here. So W is equals to d 4 pi r by lambda by dt, where 4 pi lambda into dr by dt. So only r can be changed with respect to the time. So dr by dt we are calling as Vr is the radial velocity, that is rate of change of range with time. So here we can write W is equals to 4 lambda Vr by lambda. So Vr is equals to V cos theta. The relative velocity may be written as Vr equals to V cos theta. When V is the target speed and theta is the angle made by the target trajectory and the line joining radar and target. When theta is equals to 0, then the Doppler frequency is maximum. When theta is equals to 90, the Doppler frequency is 0. So by this, W is equals to d phi by dt and 2 Fd is equals to 4 pi by Vr by lambda. So here the Vr cos theta, the theta is equals to 0 degrees. So I am getting the maximum Fd value. So Fd is equals to 2 Vr by lambda. If the Doppler frequency Fd is in Hz, Vr in kilonewtons and wavelength lambda in centimeters. So then we are changing that Fd value is equals to 103 Vr kilonewtons by lambda in centimeters. Fd is equals to 1.03 volts kilonewtons by lambda in meters.